Hello and welcome to my YouTube channel. Today we will examine the regression method and apply Excel formula for predictive data analysis. Regression is a valuable tool for prediction and decision making, enabling data-driven decisions among business and researchers. We discuss how linear regression can be used for prediction. Regression can be of different type. We will be use the simplest one, that is linear regression, and this method is also popularly used in different field. For example, in finance, in economics, even in science, social science, for predictive analysis and forecasting. And I request you to subscribe to my YouTube channel and click the bell icon for notification. If you find the content is engaging, please provide a thumbs up and share my videos. Regression is a statistical method used to analyze relationships between variables. It predicts values based on given data. So it is a statistical technique used to predict one variable based on another variable. That another variable, that independent variable, can be one single variable or can be multiple variables as well. So based on the value of the input, we find out the output. It helps us to understand how independent variable affect a dependent variable. So the feature of regression is it helps in forecasting and prediction. For example, predicting sales amount based on advertising spent. So in this particular example, we have two variables. Our output variable is the sales because we are going to predict it. So sales is the dependent variable, that is, if I take it as y, then the independent variable, that is the advertising spend amount, that I can place it in the variable x. So using x and y, we frame a straight line equation. That's the basis of linear regression. Next feature of regression is it identifies relationships between variables. So using this regression method, when we get the values, we check some parameter values, and based on those values, we can also find out whether the variables are related or not. If they are not related, then framing the regression equation is of no use, and then for predictive analysis will be wrong. So that we can do. Another feature is that this particular method is used in machine learning. So today's era, there are a lot of AI tools which are used in field of economics, finance. So those AI tools may be created based on this linear regression as well. So let's see how we can solve the problem and what are the let's delve into the details of regression to understand which values we had to focus in and how we frame the equation. Then we do some problem solving. So please stay tuned. So we can see there are different types of regression. In this video, we use linear regression formula. We have the problem which we can solve using linear regression. So it's a straight line relationship between two variables. And we frame the equation using the straight line equation, that is y equal to mx plus b, where m is the slope and b is the intercept. For example, predicting house price based on size. So if the size is provided, that is the independent variable, that is which is x, based on that we can predict the house price, that is y. But sometime only size may not be enough. Okay, there can be some other input values like x1, x2, x3. Based on that, the value of y can be predicted. So that is multiple regression. What is multiple regression? Uses multiple inputs to predict an output. Predicting a car's price based on its age, mileage, and brand. And the third one is non-linear regression, logistic regression, when the relationship is not a straight line. So, for example, polynomial regression. So, the linear regression overview is that we find this equation y equal to mx plus b. So, it helps to predict the dependent variable based on an independent variable, and m is the slope and b is the intercept. So, b intercept means when y that is the y value when x is 0, and slope is change in y for each unit of x. So how to perform this regression calculation in Excel sheet? So after entering the data, we find the regression formula in analysis toolbar. So by default, the analysis toolbar may not be visible if it is if your software is installed in a normal way in your system, but that add-in feature is with the software. You just have to add in and then it will be visible. So in formula tab we don't find regression function, but in analysis toolpack we shall find out. All this we try in the after some time, and then once we get this regression formula, we input those values and we just click on OK and we generate the result. So we don't have to do much we don't have to give much effort in manual calculation. The result will be visible on the screen, but we have to focus on few values. The first one is p value. P value must be 0.5 or less than that. Then the variables are statistically significant. In regression analysis, a p-value indicates how likely it is that the observed data could have occurred by chance. So if it is less than 0.5 or equal to 0.5, then we can further go for framing the regression equation. And next is that we focus on R-square value. What is the interpretation of R-square value? Closer to 1 means better fit. So R-square is actually used that how well a regression model fits the data. It also known as the coefficient of determination. R squared 1 means regression prediction perfectly fit the data. If it is near to 1, the same thing. So if R squared is greater than 0, the model explains some of the variability in the data. Otherwise, the model does not explain much of the variability in the data. So if that is the case, those independent variables may not be used in the regression formula because that has no impact on the prediction. And R squared is used in machine learning to evaluate the quality of the regression model. So once the regression model is created, then R squared has to be checked whether it gives this whether it gives the correct result, whether the model is strongly whether the model is strong enough in case of predictive analysis or not. So let's try get some problem statement, and then let us try to solve it in Excel using Excel regression formula from data analysis toolpath. Before going to the problem statement, one thing to mention that if we want to visualize the data, then along with the means regression, linear regression methods and formula, we can also draw plot. We can have a scatter plot and with the trend line. Then it will help us to identify the pattern as well. A company wants to determine the impact of advertising expenditure on sales revenue. Here, 10 months data given. So then based on this 10th month's data, if someone asks to predict for December or next year Jan, so that can be done using uh, this regression equation. But before that, let's see what we have to ask and how the data are given. Here, two columns are visible. That is the ad spent in thousands dollar. The unit is dollar, and sales amount in dollar, and it is also in thousands. That is for in January ad spend was 5,000, and sales for that the sales revenue was 20,000. Similarly, in February, it was increased to 7,000, and then sales amount 25,000. So here, if we try this regression formula, then we can find out then that whether this ad spend and sales are really correlated or not. And if they are correlated, then we frame the equation. Okay, so what task we have to do? Use Excel regression analysis to perform linear regression, and then we frame these equations, regression equation, and interpret R square value and determine how well advertising spend predicts sales. And I hope you understood here Y will be sales and X will be ad spend, because based on this independent variable value ad spend, we predict the sales revenue. So let's try this in Excel sheet, and it will take just few minutes. So let us see where we find the regression formula. But before that, you can see that the data is already entered in a new sheet. And now if I go to FX and type regression, or if I go to formula and then under more functions statistically, if I check one by one, I will not find the regression functions over here. So in this when the software is installed, so like all these are available by default, all these are visible by default, so that regression is not available. But nothing to worry, we can get it from by attaching the add-ins in our system. So how I do? Click on Office button, click on Excel option, go to add-ins. Then below in this window, below we can see Excel add-ins. Click on Go, and we now use Analysis Toolpack. So these are the add-ins available. So anytime we can get in our system and in our software, and we can use it. to get some advanced features. Now, let's check whether it's coming or not. See you under data tab, this data analysis tools available. And now I click on this. I go for regression. Okay. Then this small window comes. I have to fill in input Y range. So Y range is cells which we are going to predict. We should not take any non-numeric value. We have to keep it in mind that heading will not include because only numeric data we have to enter. And then in X input range, these are the cells. The cell range is from B2 to B11. Now we can get the output in a new fresh worksheet, in a new workbook, in new Excel file, or I can get it just beside this table in the same sheet, okay, by clicking this option and choose area to generate the output. So here, suppose this portion I am selecting and click on OK, and I get the result. So the next work is I can format it also little bit, but the next work, important work for us is to check two values. That is, one is p value, that is to find out whether they are statistically significant or not, x and y. So you see here, this is the p value column, and you see this value. This particular actually value is given in scientific notation. So this is 10 to the power minus 9. So it is much less than 0.05. 0.0, it is less than 0.05. So they are actually statistically significant. If I like convert it into general number, you can check this out. It's a much less than that 0.05. That's why they have given the result in scientific notation is 10 to the power minus 9. So now in number, in format cell, in number, if I take decimal places, for example, 15, so maybe then I can see this value. So this p value I am highlighting because that's very important to check, and also the r squared. This is also very important. Okay, because using this intercept and x variable value, I'll be framing my equation. But is that equation can be used for predictive analysis for this case? Yes. In this case, r square is near to 1. So then that equation will give a correct result. The regression prediction perfectly fit the model. Okay, so it's satisfactory. So let's frame the equation. That is, the regression equation will be equation that will be what? The structure is like this. This is a form. This is actually the formula of a straight line equation, general formula of straight line equation, where m is this value and intercept is this one. So let us write it. Y equal to 2.567044. That will be multiplied with the value of x, plus intercept is 8.34797. So our equation is also framed. So whatever task we are asked to solve, we have done it. We let us do something extra. Like suppose another question is asked to you, that find out the sales revenue in December, where the ad spent in December is $30,000. So in December, if the ad spent amount is $30,000, $30,000, 30, because here we have written the unit and it's coming in thousands, so 30. And then what will be the our question is, what will be the sales revenue? So this is our question. So this is our question. If I have to solve it from this equation, we can easily do that. Okay, what will be the value? So here the value will be equal to, see, this 2.5670, this particular, okay, that slope multiplied with star symbol, multiplied with what? 30, that is x value, plus this intercept, enter. So the result is also coming in dollar. We can round it up also. So that is $85,000. That is the sales revenue in December if ad spend is $30,000. So with this, we have solved one problem. Let's try another problem, another similar problem. The next problem is that a real estate agent wants to predict house prices based on their size. Size is given in square feet, price is in thousands, in dollar, unit is dollar, and in thousands given. That is 150 is actually 1,50,000, 1,60,000, and so on. So I know 10 set of data is given. Now, task number 1 is use Excel's regression analysis to determine the relationship between house size and price. Second one is find the equation of regression line. And third question is to predict the price of a house with 1,750 square feet using regression equation. So the same way we do and do the prediction for this value. When the size of the flat is 1,750, what will be the price of the flat or house? So let's enter this data in Excel sheet and try this. So we have the data here, and we go to data tab, data analysis, click on regression, okay, and do the selection. Here we are going to predict the price. So Y range will be from only the numeric value. Don't take, we should not take the heading. So from C2 to C11, and this part will be B2 to B11, and we are generating the result in this current worksheet only. We can take 95 confidence level as well, and we can also have try out this plots, normal probability plot also. You can try this by clicking this checkbox, and then we click OK, and we get the result. And with this result, we can frame the equation. But before that, let us check R square value. Okay, so if we create the model that will give us correct prediction, because the regression prediction perfectly fits the data if r square is 1 or near to 1. So now this portion I'm highlighting, and this is also, p-value. It is much less than 0.05, because it's given in scientific value 10 to the power minus 12. So if we change the format cells, go to number, and decimal place, if we make it like 20, okay, so you can see it's much less than. So in this case, y equal to mx plus y equal to mx plus b. So for this particular case, the y value will be equal to m is 0.173692 plus 1.278315. So the equation is already framed, and this equation can be used for any prediction. So we are asked to calculate the price of the flat if the size of the flat is 1750 square feet. So if size, that is x, is here, x is missed. I have used capital X as variable. So if it is given that is in the unit is in square feet, so if it is given the 1750, so what could be the price? Our price values will come in dollar. The unit is dollar, and in thousands it is coming. So let's do the calculation. Equal to this value multiplied with 1750 plus this, intercept, enter. So it will be, if we round off, it will be 305, almost 305. So the price of the flat will be 3 lakh and then $5,000. So with this, I end my video today. Thank you for watching. And if you want to try that probability curve, let's try once. Data analysis, regression, dollar selected. We can see the probability output, and from there we can draw a plot. see you in the next video. Thank you so much for watching.